Good morning, this is Cody Henriksen. Today we're going to be looking at how we can do Swift objects, the classes and structures that make up the foundation of object-oriented programming using Swift. And this is from a 4.2 plus perspective, so if you're looking at Swift before 4.2, you want to definitely take a look at any changes that may have been affected by this. But hey, it's 2019, here we go. When we look at the class, it's pretty similar to what we see inside a Java class. And so again, I'm coming from a Java perspective when I first started working with Swift, and so I'm going to use that as the framework we're going to be looking at through this. Data members and methods are almost the exact same inside a Swift class. We're going to see a little bit of a small difference. We don't use the new keyword when we create an object, which is probably one of the biggest, huge changes you'll see on the use side of a class inside Swift. However, also we have a small change on the idea of a constructor. We don't have an explicitly thing that has the same name as the class and the file. Rather, we have the init, which is used to explicitly create that. And this is a holdover or a pullback from the Objective-C history that Swift comes from. Swift look the same. I always like to keep the same pattern, having all my data members / properties at the top of the file, then my inits together, and then finally the methods actually go along with the class, grouped by things that make sense. And so that same pattern of structure of code works really helpful, but it's not required for the actual writing of the code itself. But hey, that's what we're working with. Let's take a look at the idea of visibility, aka access control. So in Java, we have a visibility of public and private, only two real words. We have protected, but we don't have to worry about that. But we have visibility also has the same thing in Swift, but we have a little bit different approach. We have the internal keyword, which is also used with the not having a keyword at all, which means that the code that you're referencing without a keyword or with the internal keyword is going to be visible to the entire project, which means there's not the import package structure that goes all across the top of your file as the first line of code in like in a Java file. So if you have multiple groups organized for making, say, for example, a very complex project, be nice and compact and little things that make sense for you. You don't have to worry about having a weird package structure you have to worry about for importing, because the entire thing is by default visible and accessible within your structure. You just have to make sure you access and use it in a model view controller approach. You have still the same public and private keywords. There's some other keywords that can go along with that, but public and private work just like they do in Java. Public means externally available, private means it's only local to the file. And it's a great way for doing specific visibility, especially on methods and even inits, but especially methods. We're going to see the most use of how the visibility of methods work on that. Data members, however, they get compound access. Because of the magic power of a property, you can have a public getter with a private setter. I know, it's amazing. We'll take a look at that in the future. The first thing we want to look at, though, when we're looking at the class is the idea of the init. This is how you create the object, just like the constructor in Java. Just like in Java, there's no return type. However, we don't have the same name, so you have to make sure you use the word init. But what we do a little bit different, and also that carries over from the idea of Objective-C, is you have a nice long name use of when you're using your actual data members that are assigned to build the actual init, especially if you're doing a custom init. And so it's like, oh, init with value, or init by the blah, 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 or init because of blah, blah, blah. That way you actually, oh, I'm using this init, and use the nice naming convention built into the external name, so you actually know what you're using when you're building that. You do have a default init that belongs to it, but you have to then, at that point, make sure that every single data member is explicitly initialized with a lazy or closure, or as a default value. And you don't always want to have everything have a default lazy or closure value, so not really the best choice. Just like a constructor, you call in without the use of the new keyword, like I said. So we have var some examples, a famous computer scientist, and so it works just like that. All data members, however, this is one of the reasons I really like Swift over Java and some of the languages I've worked with. Every single data member must be explicitly initialized or declared as lazy, or have a optional before compilation will happen. You can't just like, ooh, I forgot to initialize all my variables. No, you have to explicitly initialize every single data member. So when you're designing your classes and making sure you're working out how you're going to put together your object and designing your structure, you have to explicitly make sure you initialize all that, or it won't compile. That's going to solve so many problems, especially with beginning programmers. There's no good excuse for a no pointer exception at this point, because it won't even compile. So if it won't compile, you shouldn't be getting MPEs. If it has the same signature as the parent, you must be marked as an override. So in Swift, you have to explicitly mark things when they're changing from the base class. And so that's where the idea of override comes into play. It's a keyword you just put in the front of the actual method or init. And just it's really pretty easy. We'll see an example here in just a bit. Now, one of the biggest changes, one of the things you have to explicitly make sure you look for, is that when you're using the idea of inheritance, which we'll talk about as well, you have to call the super init after all of your local level variables are initialized. Now, this is the exact opposite of Java, where the first line is the call to super. In Swift, however, the super call happens at the end, at the bottom of the init. And so that was where you actually initialize all your local data members, and then you go back to the parent class and do its initializer. And you call it by doing super.init. It's not just super parens, it's super dot. And that way you can make sure you're explicitly calling the initializer. Here we have a couple examples within that. So you have the init has flowers true, interest of running, flowering parameter on that, so init flowering has a Boolean parameter, and we assign that variable to that. And then in my subclass, I have an override init with the keyword override right there in front of that. And then the topic is computer science. Familiarity is 1. Self.familiarity is also 1 because I have to explicitly initialize all of my local variables. And we can use the self dot just like we use the this dot inside Java. And so we have that happening right there. And as you can see in both of the inits in the subclass, I call super.init after I've initialized my local data members. And data members and properties also have a couple small changes from Java. It's a little bit different way of approach. It's more of the modern language approach we see in other languages, including C#. Swift designers, the language designers, are sick of having programmer cause crashes, and so we have again the idea that every single data member must be explicitly initialized, provided lazy, or be an optional, question mark, exclamation point. Get to that another time. But lazy modifier means that the constructor or a closure must be provided to construct that variable. So you have to explicitly have values for everything. This is on you, the programmer. Make sure you write code that's good as you start off. And that way it's like, oh, I know what I have to actually do. I know what I'm doing and why I'm doing it. And you can have that built in ready to go. Swift requires that every data member must be typed. This can either be done explicitly or implicitly. An explicit one is what we see right here where Grace Hopper is a famous computer scientist. So var Grace Hopper is of type famous computer scientist. However, we also have an implicit where this is of string type, where let phrase equals Katherine Johnson should be as well known as Alan Turing. Again, computer scientists should be really well known. You want to do also to think about the required visibility. Do these things need to be externally viable or visible? And so should they be marked as either internal or public? Or are these things that are only local to the actual local area, aka only the class needs to know that internally, and that can be marked private? So again, this is where you think about what your design is doing, what needs to be accessed and how, and that's something you want to look at when you're actually looking about how to actually design a class in another time. Properties explicitly are how we can actually access the data members that belong to a Swift class. Now, unlike Java, where everything should be a getter or setter that's attached to that, Swift follows the approach that we see in C# and other languages where we have the idea of a property. Now, unlike Objective-C, where there was a stored property and you had to have that make sure it had separated properly from the right data member that belongs to the class, Swift doesn't worry about that. Swift has made this a lot simpler, makes it very easy to do, and so you have the property directly assigned that you can be as part of the object and have it externally available via dot, which makes it really nice. So we have a stored property, which is like a public and getter and setter, but it's not separate from the data. You just define it as a var or a let. It's right there and it's available outside of the file, internal to the actual project itself, because the internal keyword is by default. And that's a property that's available to the entire project. You can actually access either with a sign into with an equal sign, or just retrieve it by putting it inside a value. We also have a computed property. Computed properties are a little bit different. This is where I want to be able to access and or change value, but I don't want to get a direct value. Rather, I'm looking to actually access and modify some other data and then retrieve something from that. And this is a great way to have complex relationships that we don't need to get internal components of something, but rather we need to get the results of something, aka computed data. Weird, I know. We also can have the ability of having a public set, excuse me, a public get and a private set. And you can actually have it so you can have the variable is accessible publicly just for retrieval, but cannot be changed externally. Great way to do by doing private set var and having it right there for that. You can take a look at that, some other examples as well. Now, one of the really powerful things of the property is also allows for observers. And an observer can actually watch for a change to happen to a value or variable. And when that value or variable gets changed, it can then cause other things to happen. Really good thing, especially when looking for apps and using the idea of the did set. So you can have something happen, oh, I made a change, I need to cause my GUI to update. Great thing we can do with that. And that's you can see in some other videos we've worked on. Here we have a property example. So in the public class person, we have a private data member var has flowers. So it's a true or false value because it's of type bool, and it's private, so it's only visible inside this actual class itself. We also have a stored property. Because I didn't mark it explicitly private, therefore it's internal by its default visibility. And we have the interest is of type string, so it's a stored property. I can either retrieve that string or I can set that string by using an equals assignment operator. I also have a computed property with a string, so var phrase is of type string, and we know it's a computed property because of get and set, and it's actually looking for something completely separate, where return interest is so cool, or self.interest equals interest plus backslash and a new value. And the backslash new value right there, inside the string interpolation, the backslash parens operator that we're seeing right there, new value is the implicit let that's available as a parameter when I try and assign something into a property. And so that's where I can actually get access to that right there. I can also give it a variable name up on the line set, but new values, especially for simple values like this, works really, really well. As you can see, I still have my inits that go along with that. We can see the example of the property over here on the right-hand side. And so let me is of type person. I'm going to print my interest. I'm going to print my interest. I'm going to assign that then to be Swift programming. So that's where I'm going to go over and assign the interest because it's a stored property right there. So I can use the equals and assign into it because it's a public property. So that allows to Swift program to go inside that interest value instead of the default value of running. And then my phrase is going to be assigned to be allons-y. So I now have allons-y, it comes in, it gets a set. I'm going to take the existing interest value, add a \n, and take that new value, allons-y. And so it's running and allons-y. Interest is going to be Swift programming, then \n for a new line character, and then allons-y. So Swift programming allons-y is now my new value inside interest. So if I were to print interest again, it'll print that out. Or I can also just print phrase, which will also print interest allons-y. Okay, great stuff where I actually combine the values together and work with that. Not really, it's a little bit contrived, but so love you. We also have the same thing over here with a subclass on that with Ada Lovelace is a famous computer scientist with a topic of algorithms. And so I can print her topic using the .topic, which accesses the topic of that, which is a property of the subclass, and I can access it that way. I can also access the subclass interest that belongs to the parent class, just in the same exact way where I was doing the equal sign and creating music with the analog engine. And I can retrieve that value with using .interest and how:\y.reason to access the internal components of that. So we can see some great examples with that. Let's go ahead and take a little bit further. One of the things at the heart of an object is the idea of using methods. And so methods in Swift look not really that similar to Java. That's okay. Methods in Swift have the keyword func at the very beginning. And so at the very beginning, it automatically explicitly, oh, this is a function, this is a method, I have to actually do stuff with this. We then have the name of the method, followed by the parameter sequence, and finally the arrow indicator and its return type. Now, Swift, like I said, continues that naming convention where you want to have a really long name that explains exactly what's happening. Swift has totally stepped away from the really horrible, in my opinion, C/C++/Perl idea of let's take out all the vowels, all the things that make sense, and squish the name into something tiny. No, we're not looking for code obfuscation. Code obfuscation is only good if you're trying to prevent code from being understood by other people, especially when you're learning how to do computer science, learning how to program, and you want to work with other humans. You don't code obfuscate. We write code that makes sense. And so Swift really has taken that as an approach where we're going to make sure that we make methods that make sense, and that when we name the variables, those names also make sense, so we can actually build a method name by including the variables that are passed to it, so we know exactly what's going to be passed at the spots inside it. We also have a really cool power value of tuple. Now it's not number tuple, but they're a tuple. And a tuple is a way you can have multiple turns in a single method. Great, fantastic tool. You don't always need a full object for something. Sometimes you just need a whole bunch of different values you want to pass, and it's not something that can be easily put into an array because there are two different kinds of things, or 18 different kinds of things, but you need access to all that. And that's where tuple comes into play. And so it works really well. You have a return, parens, name, colons, values separated by other name, commas, in parens. Yep, pretty easy. And a signature, the best way is like name, type, other name, type, really easy to read. But unfortunately, you can also do really crappy compilation stuff where it's just type. No, don't do that. Sad kitty face. No, we don't want that. We want good code. And as we can see right here, we have a sample right here of a method. So private func demo is of type double, or returns double. And we have a couple different bits of math, and it returns a double from that information that's retrieved from that. We also have an overridden function, viewDidLoad, one of the lifecycle methods of the view controller, and it's a void type. I added the keyword void because void is not explicitly required to be attached to methods, but I myself like always having a return type explicitly stated on my method, so I always add void to my default method types. We have a tuple example as well, and so we can see how that's working right here. So I have my public func is how cool and why, with cool as an int and reason as a string. And so let coolness be the self-interest.count times 130, because we want to have a really high coolness count, exactly. And then why is because of the work in their topic as comp sci in general. And then return coolness, reason why. So that's going to retrieve the value and put into that, and using the idea of having a named variable going right for that. The cool is the coolness, the reason is why it's cool. And so we have that explicitly defined right there. And we're ready to go. And then we have the example of that on the Let Lady Ada Lovelace. And so I have that topic and interest right there. And then I can access the values from within that tuple by calling the method is how cool and why, and then the dot, and accessing the individual components within that. If I was using an unnamed tuple, aka I wasn't smart, I just had int or int string or int string int, I'd have to keep track of 0, 1, 2. No. You give it a name because it makes sense. Because that way you can actually come back, read it, and understand what you're asking for and how you're actually getting that out of the value. And that's actually a better way to design code. When we're talking about inheritance in Java, everything is based off of a class. In Swift, however, it's a little bit different. There is no automatic inheritance hierarchy in Swift. I know, not automatic. It's a little bit different. There is no base class a la object that we see inside Java. Swift uses the C++ and the C# inheritance style, aka the colon, in the class header where it defines what the class is. So public class colon class that inherits from, instead of using a keyword like extends in Java. Subclasses must explicitly override methods or their observers. So if you're going to be working with something you want to change the way it works, you have to explicitly override it. Unlike Java, where you can just like, oh, I'm just going to override this, I'm going to override that. In Swift, we must explicitly state that we are overriding method. It's not going to, it doesn't want you to try and well, I think I might override it. No, you have to explicitly do this. This is something you have to plan in advance. Again, design code is almost always better. And again, when you're calling the parent class as init, you do that at the end of the init. I know I've already said that before a couple times, just can't repeat it enough. Calls to the parent class init happen at the bottom of the init, not in the top like it is in Java. Here we have an example of inheritance in Swift with public class person. And we have the person class over here on the left. On the right, we have our subclass, well, at least the top half of it, that is. And we have public class famous person colon person. So famous computer scientist is the new subclass. It's of type person as a parent class. We have the colon right there indicating that. We have the explicit overriding of the init because when we have our own init, we have no parameters. We have to explicitly say that it's an overridden one. And then we call the super.init after we've initialized our local data member, in this case topic. Topic gets initialized after I do my other work. Topic gets initialized first, and then I call the super init. And again, unlike Java where it's just superparens, no, it's super.init because we are explicitly calling the initializer for the parent class. And again, it's the idea that we have a design structure a little bit sometimes better than Java. So it's one of the reasons why I really like Swift and how it can do some really cool stuff. Now, protocols, I have an entire video on, you can go watch that another time, but a protocol is even more powerful than the corresponding Java interface because it can do so much more. Protocols in Swift are way more powerful than this corresponding interface type in Java. They keep the same approach where we can have a whole bunch of different features feeding into that for the idea of polymorphism. However, with a Swift protocol, we have a lot more functionality and capability than we do inside a Java interface. A Swift protocol also allows for the ability to have inits specified. So you can explicitly require a certain init for all your classes that conform to or adopt that protocol. And we can take a look at that. Inside my protocols video, I have another example of this. We also have the fact that Objective-C, older protocols, have the ability to have optional methods, methods you don't have to have. And that's what you will definitely look at, especially when looking at the idea of the view controller subclasses and those things that you're working with, because sometimes you don't need to do all of the methods, and so some of those methods are optional. And that's another thing you can look at for another time. And a protocol also can be applied to struct, something that doesn't exist in the Java side, which we'll be talking about in just a bit. But if a protocol is attached to a struct, you have to plan for in advance that if it's going to be a mutating thing, it's going to change the internal state, you have to explicitly define that it can mutate that state by using the mutating keyword. We also have a couple subsets of protocol. We have the delegate type. The delegate type is a protocol that's designed to hand off the information to something else. Okay, you're going to be the delegate of this, which means you're responsible then for that other set of actions. Weird. The English definition actually matches what the computer science definition is. I know, it's so crazy. We also have the data source type of protocol. And this is like, oh, these are the rules for dealing with this type of data. It's basically just a special delegate, but the data sources are something you see, especially when you're talking to data inside of your UI kit-based classes, a way to actually handle information with that. We skipped over this until now. A struct is something that we have inside Swift that we don't have in Java, so it's not really something you can really compare to. A Swift struct is actually what they recommend that you use for when you're designing all of your project structures and stuff, and you're actually thinking about how to put together your project, especially on a large-scale project. You want to use a struct instead of a class for most things. What it's going to ask you to do instead of having the idea of inheritance via the class itself, you pass the inheritance on to the protocols and use the protocols to do all the inheritance components, since protocols are inheritable and they can use that whole inheritance structure. And structurable or lightweight, and more specifically, structs are a value type, which means you get copies of things, which means it's going to be, especially because of the high level of work that's been done to the Swift language, that means it's a very efficient way of handling the different components within the actual struct. Now, there are a couple limitations we get with a struct. There's no inheritance, and if you want to actually have something be changed inside state, you have to deal with the mutating keyword. Oh, so sad. Tears. Okay, so the big thing in Swift is that almost all the actual default data types are all structs. So int double string are actually all structs that map over to the corresponding stuff that was back on the back end side of Swift. And so you've actually been using structs the entire time. They just work almost exactly like an object when you're dealing with stuff. So it makes it really quite nice. We can have a default init that all structs get. This is something that we sometimes will often use if you have a data member for that. And so what happens if you have a struct that has 8 data members, you get a default data member in the order that's defined, defines all those data members right there. You can also have a custom init, but if you use a custom init, you wipe out your default init. Okay, so just like Java. Now you can have private data, but it must be defined. So yeah, that's what you have to actually change and look at. But again, because Swift has that internal keyword, and when you're using the idea of internal structure, that's what you can actually look at when you're dealing with the properties and stuff with that. And methods in struct look and work just like those in a class. Oh, amazing. Really great stuff. So let's take a look at that right here. So I have an import foundation of my CodeArt class. So we have import foundation, not actually needed for this one right here, but we have a struct called CodeArt. It has a couple lets for constants as well as a var, and a private var bad design, which is a type string, because there's no reason to have that there. I just throw it in so you can actually show that you can even have private data in that. And then as you can see right there, I have self.width, self.height, self.content, and self.badDesign. And then I have a customized init where it's going to be like, oh, height is of type int, content is of type string, and width is of type int. And I assign all those values as well as assigning my badDesign. And again, by using this, the order itself doesn't matter. We also have one that uses the foundation where I can use the arc4random method. And then I have my struct zombie head. It has a degradation percent that's of type double. A var that is fleshy is also of type bool. And I have a private func demo, which is a double, and a private maintaining func update. You'll notice that I do not have explicitly an init. However, when we take a look at the example right here, we have this example. I'm going to say var first zombie is a zombie head. Degradation percent 0.2 is fleshy true. Hey, that's the exact order that they have it right back here inside my actual struct. And so I have a created init, a default created init that happens from the order of my data members in order as I define them in the file. It puts them right there, boom, ready to go. I also have my code art, my default init with that, and my code art init that takes 3 parameters. I can call methods and exact work just like it does normally. If I don't do it correctly, I have obviously a set of errors with that. And so if I try and create a zombie head using parameters, which it doesn't have, is fleshy true, degradation percent 0.2. Oh, it's out of order, so it has degradation percent. It must proceed the call to is fleshy. So I have to actually make sure I put it in the right order. And if I call one that takes no parameters, in the case of the one with the code art, width, height, and content, it doesn't work that way because I actually have one that doesn't take parameters in that order, so it doesn't work. So again, structs are the idea that we can have a lightweight class that we can actually use some cool stuff with. It's something you might want to take a look at for doing some more advanced programming, but for right now, it's just as a little side note because again, we're coming from a Java perspective, and so I didn't go as much detail into structs as I could. That'd be a great thing to look at another time. But now we're going to move on to something that's even cooler than simply a struct or a class inside Swift, and that is the extension. So extensions are where Swift allows for some really cool effects to happen inside the code. They realize that when they design Swift that sometimes you need to be able to make access to and work with in objects that aren't your own. Sometimes you need to add functionality, things that weren't there in the first place, or you found, oh, if I change this right here, I can actually have a better functioning project, I can have a better design thing. And I can do that by adding a functionality to that type. And that's what an extension is. It allows me to add functionality to types that whether or not they're mine or other, that can actually add functions to, not functions. I can add components or functionality to those by adding to it. And it's going to be added for anything. Anything inside Swift can have an extension on it, including built-in types, which is amazing. And you can put them in any single file in your project. I myself, I'm really boring. I like to keep them in the extensions.swift file in my resources group inside my project, because that way I have them all together, I know what I'm working with. And I try and just put them all together so it's really easy to keep track of what I'm working with. But you can honestly attach them to anything that's going to be working with that and just put them at the bottom of the file. But keep it together makes it really easy for me to actually keep track of it, and we'll show it right here. However, you do want to make sure you maintain your model view controller separations in your project because, again, with Swift, that's one of the things that's at the heart of the language. We want to try and actually make sure that the code itself knows where it belongs, so we don't want to try and add too much cross-functionality to make the code messy and yucky. We don't want to repeat the 1980s. We're doing better than that. Now, right here, we have some examples of custom classic extensions we can use. So I have an extension on my previous structs of zombie head and code art. My zombie head class has an extension on it called spooky. It's a void method. Oh, it's going to print boo a few times. Woo, amazing. I know, crazy. Then I have an extension on my code art class. My code art class has a var on there of type int that returns height times width. Oh, that's an area. Okay, I have a computed property, so I can add a property extension right onto my code art class. I also have added an init via extension. In this case, I'm going to pass an area, and I have it do double dot square root of area. I know, useless, but it's a great little example and actually show something. We can say, oh, hey, I'm going to have the square root value be my length and width to put for that. Okay, that's what I'm doing. So I actually build a thing on that right there inside that. But not only can I do custom class extensions, I can do an extension on string. So here's my string extension, my utterly useless method. It's a void type, and what does it do? Nothing. Yes. Okay? But I can also have overloaded. So function overloaded on a string type and now returns an int, and this returns self.count. Why? I can. That's why. So let's see what it looks like. So extension samples, as we see right here, words is a type string, sample for extensions, and I can print words.overloaded word and words.utterly useless method. It works. It compiles just fine. It's right there. It does nothing. It's great stuff. And I have my var struct sample as a code art, and I say pass it area of pi, and then I set its content to be sassafras, and I can print that area. And same thing with zombie. I make a zombie be a zombie head, passing a degradation percent of 0.8345, and it's very not fleshy. And let's say that's spooky, and it'll print boo a few times. Great example right there. So extensions provide us the ability we can do some really cool stuff, and it builds right inside our project and do some really cool things on that. So again, some great stuff we can work with. So we looked at classes, we looked at structs, and we looked at extensions, and the idea of doing object-oriented programming using Swift for too. So we can do some pretty cool things inside class. Take a look at some of the other videos you can do and how you can do things inside Swift, and have a great day. Thanks.